here's something that will genuinely break your brain today. If you shrunk the sun down to the size of a white blood cell, something so small you'd need a microscope just to see it, the Milky Way galaxy would still be the size of the continental United States. Let that sit there for a second. One galaxy, the size of an entire continent. And we know of at least 2 trillion more. Most of us have heard that space is big. We've nodded along. Yeah, space is really big. But we don't actually feel it. We can't. Our brains weren't built for this. And today, we're going to fix that. By the end of this video, you won't just know the scale of the universe, you'll feel it in your chest. And it might be the most humbling 8 minutes of your life. Let's go. Welcome back to the channel. I'm so glad you're here for this one, because this is one of those videos I genuinely wish existed when I was first falling in love with space. Here's what we're gonna do today. We're gonna take a journey, starting right here at home on Earth. And we're going to zoom out, step by step, layer by layer. From our neighborhood in the solar system, out to the stars, out to the galaxy, out past the galactic superclusters, all the way to the very edge of the observable universe. And at each stop, I'm going to give you a real human-scale analogy, something you can actually picture, so that the numbers don't just wash over you like they usually do. Because here's the thing about space distances. The moment someone says 93 million miles to the sun, most brains just go, big number, sure, and move on. We're not doing that today. We're going to earn this scale, one step at a time. Let's start somewhere familiar. Earth, home, about 8,000 miles across. If Earth were a basketball, the moon, our closest neighbor, would be a tennis ball sitting about 23 feet away. That's actually pretty far for something we think of as right there. Now the sun. At the same basketball scale, the sun would be about 15 feet in diameter, basically a small car, and it would be 1.5 miles away. 1.5 miles just to reach our own star. But here's where it starts to get weird. The speed of light, the fastest thing in the known universe, travels at 186,000 miles per second. It crosses the entire United States in about 1/50th of a second. Light is ludicrously fast, and yet, sunlight still takes 8 minutes and 20 seconds to reach Earth. When you look at the sun, please don't. You're not seeing it as it is right now. You're seeing it as it was 8 minutes ago. You're looking into the past. Now. How far does our solar system actually extend? Most people think sun, planets, done. But our solar system, the full bubble of space influenced by the sun's gravity, extends out to a region called the Oort cloud, roughly 1 to 3 light years away. That's years, not minutes. Years of traveling at the speed of light, just to leave our own solar system. The Voyager 1 spacecraft, launched in 1977, still the farthest human-made object ever, has been flying through space for over 47 years. It's traveling at 38,000 miles per hour. It has barely left the driveway. Okay, so our solar system is already mind-bendingly large. Now, let's zoom out to the stars. The nearest star to our sun is Proxima Centauri, about 4.24 light-years away. At Voyager's speed, it would take roughly 73,000 years to get there. If humanity had launched that spacecraft when we were still painting on cave walls, it still wouldn't have arrived, now. Here's the analogy I want you to hold on to. Imagine the sun is a grain of sand, a single grain. You place it on a table. The nearest star, Proxima Centauri, on that same scale, would be another grain of sand sitting about 4 miles away. And between those 2 grains of sand, nothing. Just empty space, absolutely nothing for 4 miles. That is how empty the universe is, even between stars. Now, zoom out to the full Milky Way. Our galaxy contains somewhere between 100 and 400 billion stars. It's a flat spiral disk about 100,000 light-years across. If you drove across it at highway speed, 65 miles per hour, it would take you about 1 quadrillion years. The universe itself is only 13.8 billion years old. You'd need to drive for about 70,000 times longer than the universe has existed. And here is something that hits different when you really absorb it. Every single star you've ever seen with your naked eye at night, every one of them. They're all in the Milky Way, every single one. On a clear night, you can see perhaps 5,000 stars, out of hundreds of billions. You're seeing a tiny local neighborhood. The rest of the galaxy is invisible to the naked eye, just that soft smudge of light arching across the sky. That smudge, that's home. All right, buckle up. This is where the floor drops out. Zoom out past the Milky Way. We're in a cluster of about 50 galaxies called the local group. The Milky Way and Andromeda are the two big ones. Zoom out further. We're part of a supercluster called Laniakea, which contains over 100,000 galaxies and spans 520 million light-years. 520 million light-years across. One supercluster, which is itself just one of millions of superclusters. When astronomers mapped the large-scale structure of the universe, they found something extraordinary. The superclusters and galaxy filaments form a web-like structure called the cosmic web that looks almost biological. Strands of matter connecting nodes, separated by vast, dark, almost empty voids. It looks like neurons in the brain. It looks like mycelium. Nature apparently has a favorite pattern. And all of this, everything, exists inside the observable universe. Now, here's where the language really matters. Observable universe, not the whole universe, just the part we can see. Because light travels at a finite speed, and the universe is 13.8 billion years old, we can only see light that's had time to reach us. The edge of the observable universe is about 46 billion light-years away in every direction. Not 13.8 billion, because the universe has been expanding the whole time that light was traveling. The observable universe contains an estimated 2 trillion galaxies, each with hundreds of billions of stars. Do the math on potentially habitable planets, and you get a number so large it stops being a number and starts being a philosophical problem. But here is the part that truly floors me. The observable universe is almost certainly not the whole thing. We don't know how big the actual universe is. It could be thousands of times larger than what we can see. Some models suggest it could be effectively infinite. We genuinely do not know. The edge of what we can observe isn't the edge of what exists. It's just the edge of our cosmic horizon. Beyond it, there are almost certainly more galaxies, more stars, more worlds, stretching on in ways we may never be able to measure. We're not at the center of the universe. We're not even near an edge. We are at the center of our own observable bubble, surrounded by a cosmos that dwarfs everything we can conceive of. So, why does any of this matter? It would be easy to hear all of this and feel small, insignificant, like nothing we do could possibly count for anything against a backdrop this enormous. But I want to offer you a different feeling. Carl Sagan once said that we are a way for the cosmos to know itself. And I think that's exactly right. In all of that incomprehensible vastness, in 2 trillion galaxies, across 46 billion light-years, we know of one place where the universe woke up, looked around, and asked, how big is this thing anyway? Here, this pale blue dot. These curious, stubborn, magnificent humans. The fact that we are small doesn't make us insignificant. It makes us remarkable. That atoms organize themselves into creatures capable of measuring the distance to the edge of everything. That's not a reason for despair. That's possibly the most extraordinary thing that has ever happened. And on a more practical note, understanding scale matters for how we think about the search for life, the future of space exploration, and even how we treat this planet. Because if the universe has taught us anything, it's that habitable worlds aren't guaranteed. This one is precious. And it is, for now, the only home we've got. We started with a white blood cell. We ended at the edge of everything, from the 8-minute sunlight delay to Voyager's 73,000-year journey to the nearest star, to the 2 trillion galaxies sitting inside just our observable bubble. The universe doesn't just exceed our imagination, it redefines it. And that's what I love most about this. The universe keeps being bigger than we think it is. Every time we build a better telescope, pointed at a patch of sky that looks completely dark and empty, we find more galaxies, more light, more time. It's never finished surprising us. If this video gave you that feeling, that chest-tightening, dizzy, wonderful feeling of cosmic awe, hit the like button. It genuinely helps more people find this channel and feel what you just felt. Subscribe if you want to come back for more. We've got videos coming up on dark matter, the multiverse, and what would actually happen if you fell into a black hole. You don't want to miss that one. And leave me a comment below. I read every single one, and I want to know, what part of the universe's scale hits you the hardest? Until next time, keep looking up.